Hi everyone, so next video, this one's on integrating trig identities. So if we're pretty good at reverse chain rule and we know our trig identities normally, then this video is going to be nice and quick and a piece of cake. Alright, so what identities am I talking about and which ones do we need to know? Well, biggest ones, sec squared x, we know that's 1 plus tan squared x. And cosec squared x, we know that's 1 plus cot squared x. And remember, if you forget for whatever reason where they come from, you don't need to panic. As long as you know sine squared plus cos squared is 1, divide everything by sine squared, or divide everything by cos squared and you have it. You see, sine squared over sine squared is 1, cos squared over sine squared is cot squared, and 1 over sine squared is cosec squared. Okay? So we've got those two, but we've also got the idea that we know that cos squared x is the same as half plus half cos 2x, and that sine squared x is half minus half cos 2x. Okay, we must know that because we cannot integrate cos squared or sine squared without this. And again, if you can't remember, well, they've always got half and a half, cos 2x, yeah? Cos is plus, and sine is minus. If you can't remember, though, these formulas, it does take a bit of time, but you know cos 2x is the same as 2 cos squared x take 1. So to get this first one, all you need to do is make cos squared the subject. So you add 1 to both sides. So we get 2 cos squared x is 1 plus cos 2x. And then you're just going to divide by that 2. So there we go, that's where it comes from. Okay? Now let's actually use that in practice then. Okay, so if we had to integrate, so remember we're going to say let I equal tan squared x. We know from our differentiation table that nothing differentiates to tan squared, alright? So we can't do anything with that. But there is another way of writing tan squared, isn't there? Because we know that tan squared from the previous slide, if 1 plus tan squared is sec squared, then that means that tan squared must be sec squared x take 1 dx. Now remember in your new syllabus, if you don't write dx, you're going to lose marks for that. And therefore we can integrate this because we know that sec squared integrates back to tan x. Tan x differentiates to sec squared, and the minus 1 is going to go to minus x plus c. Always quick differential to check. Does tan x differentiate to sec squared? Yes. Does minus x go to minus 1? Yes. Next one, sine squared. Like I say, there's nothing, again, on this right-hand side of the differentiation table that differentiates to sine squared. But we have an identity for that, don't we? We're straight into half minus half cos 2x. And this one we can integrate. So the half is going to go to half x. And then we've still got our minus a half. And then we're going to guess. So we have back to our GDA. It's reverse chain rule. Cos 2x. Well, I'm going to guess it's something to do with sine 2x plus c, right? So here's my kind of guess. But then I always differentiate to check. The half x, does that go to a half? Yes. Minus a half sine 2x. Sine 2x differentiates to 2 cos 2x. So that would cancel out this half, do you see? This half here. So actually we need to adjust. So my differentiation, I can see I've got a half minus cos 2x. And the 2 comes out, so actually that counts as a half. And the c wouldn't be there. So I would get cos 2x, but I need minus a half cos 2x. So actually I need to adjust and change this half to a 4. Okay? So this would be my adjust column from our GDA. I just haven't got that much space. Alright, so make sure you're differentiating to check. Okay, what if we had something like this? Cot x minus tan x all squared. Now again, looking at the right-hand side of your differentiation table, we have nothing that looks like this. So naturally, that squared, I'm just going to expand the bracket and maybe something will come out. So cot squared plus tan squared minus 2 lots of cot x tan x dx. Now, straight away, what is cot x times tan x? Well, cot x is 1 over tan, and tan is obviously tan. So that cancels out, doesn't it? This thing cancels down to 1. So already, that's sorted. So if we look at these individually, I've got cot squared x dx plus tan squared dx. And now I'm just integrating minus 2, which I can put on the outside, and I could do it with 1, or I can put it in the inside, it doesn't matter. Okay, so that one's easy, we've got that sorted. Tan x, we also know there's no right hand side to that, but we will convert that to sec squared x take 1, right? So that's what we're going to integrate now. And we got this cot squared x as well. Nothing differentiates to cot squared, but we know that 1 plus cot squared is cosec squared. So we can change this one to cosec squared take 1 dx, you see? And now we can integrate this thing. Now we can do it. So we've still got our minus 2 lots of 1 dx, right? So firstly, cosec squared integrates to cot x. Quick differential to check. Cot x differentiates to minus cosec squared. There's no minus here, so I need to put a minus there. The minus 1 is going to go to minus x, that's all good. And then we've got our sec squared x, which we know is tan x. We've got a minus 1, which is minus x. And then we've got minus 2 lots of 1, so that's minus 2x plus c. So simplifying that up, we get minus cot x minus 4x plus tan x plus c. Okay? So if you get something squared like that, just expand the brackets out. Alright? Now this time, I've got minus 4. Notice how I just automatically put the constant on the outside to make things easier. That minus 4 can just stay out there until I'm ready for it, right? So I'm immediately seeing I've got a cos squared here. I know I can't integrate cos squared as it stands, but I have an identity, don't I? That cos squared x is half plus a half cos 2x. But the issue is there's a 5x here. But that's no problem for us, okay? Because if we've got cos squared 5x, all I need to do is times that 2x by 5. Because it's just an exploitation of the double angle formula, isn't it? Right? We know that if that's 5x, then that must be 10x, okay? So actually I'm just integrating minus 4, lots of a half plus a half cos 10x, which now is just a normal chain rule. So the minus 4 can stay out, big square brackets, the half goes to half x, the half can stay, cos is going to go to sine 10x, plus c on the outside. Quick differentiation to check, sine 10x is going to go to 10 cos 10x, right? So that's going to cancel my half down to 5, but I need a half. So actually, what we're going to need to do, if I expand this, so at the moment this is our like guess section, isn't it? So if I expand out, just leave the minus 4 as it is, sorry. So I need to adjust this. So that 10 is going to pop out, so that's going to become 5, but I want it to be 1 over 2. So I'm going to need to divide by that 10, okay? So plus 1 over 20, my answer would be 1 over 20 sine 10x plus c. Quickly differentiate that, check the half x does go to a half, yes. The sine 10x goes to 10 cos 10x divided by 20. Do I get the half? Yes, I do. So we multiply that last minus 4 out and we get I is minus 2x minus 1 over 5 sine 10x plus c. And we're all good in the hood. Right, tan 3x. How do we integrate tan 3x? So, sorry, just the important thing then to note about that previous question. If I'm integrating, say, sine squared 7x, that's just a half minus a half, remember, cos double the angle, 14x. If I'm doing cos squared 20x, that's a half plus a half cos double the angle, 40x, okay? That's all you've got to do. when they change the number in there. This last one, tan 3x, so let I equal tan 3x. Again, if you look on the right hand side of your differentiation table, nothing differentiates the tan. Now we've got to go back to our systems here. What is another, there's no identity I know for tan other than that sine 3x over cos 3x. Can you see? That's all I have for tan. And now we're integrating a fraction, and we should know that if we integrate a fraction, what's our first port of call? Ln f of x, yeah? And if it doesn't work, can I bring the power up? So bring power up, and then go for a reverse chain, right? This is your order of thought. And then if that doesn't work, well, we have to start bringing in other things. And remember, if we're integrating a product, your first port of call is it in the form g dash of x, f dash of gx? So quick recap there, okay? So let's look at this. We've got a fraction. Is this learnable? I.e., is the top some multiple of the differential at the bottom? Yes. So we're straight in to guess. Ln mod, always mod, cos 3x plus c. Differentiate it to check. Ln of that goes to function on the bottom, minus 3 sine 3x on the top. So I've got minus 3 too many. I didn't start with a minus 3 on the top. So I'm going to need to adjust. So we'll adjust. The final answer must be minus a third ln mod cos 3x plus c. Okay? Cool. So that's the end. Remember to box your final answers. That's the end of this video. If you know your trig identities, integration should be fine.